In this video, we are going to examine the differences between light microscopes and electron microscopes. When you try to picture a microscope in your mind, you are most likely thinking of a light microscope because these are the conventional microscopes that are commonly found in schools and classrooms. They are simple, familiar, and easy to use. One of the key advantages of light microscopes is that they are compact in size, relatively affordable to purchase and maintain, and straightforward to operate. However, since light microscopes depend on visible light as their source of illumination and visible light has a wavelength of approximately 0.2 micrometers, this imposes a limit on the microscope's resolution. Specifically, light microscopes can only resolve or distinguish between details that are at least 0.2 micrometers apart. This means that any two structures in a specimen that are closer than 0.2 micrometers will appear as a single blurred shape rather than two separate components. Therefore, while light microscopes are perfectly suitable for viewing entire cells such as onion cells, they are not powerful enough to show the finer internal structures of cells, like mitochondria, ribosomes, or the inner details of organelles. On the other hand, electron microscopes function very differently and offer much greater magnification and resolution capabilities. These instruments are very large, extremely expensive, and much more complicated to use. For these reasons, they are generally found only in professional scientific laboratories and are operated by trained specialists. The biggest advantage of electron microscopes is that instead of using visible light, they use a stream of electrons to form images. Electrons have an incredibly short wavelength of approximately 0.1 nanometers. This extremely short wavelength allows electron microscopes to reach a resolution of about 0.1 nanometers, which is vastly superior to the 0.2 micrometer resolution limit of light microscopes. Since smaller resolution values mean finer detail, this difference is significant. In fact, when you convert micrometers to nanometers, you will find that electron microscopes offer around 2,000 times better resolution than light microscopes. This superior resolution means electron microscopes can magnify samples to a much higher degree without the resulting image becoming blurry. This makes them ideal for observing the smallest details inside cells, including subcellular structures like mitochondria, the endoplasmic reticulum, and even viruses. For instance, the image shown here of a pancreas cell was captured using an electron microscope, and in it, you can clearly see the nucleus located in the center along with multiple mitochondria surrounding it. To summarize, the most important thing to understand and remember is the comparison between the two types of microscopes. Light microscopes are more accessible, portable, cost-effective, and easy to use, but they have limited resolution and are not suitable for observing detailed internal structures within cells. Electron microscopes, while large, costly, and complex to operate, offer extremely high resolution and magnification, allowing us to explore the fine architecture of cells and molecules. You will often be asked to compare the pros and cons of these microscopes in science exams, so be sure you understand both their advantages and limitations clearly. And as always, if you want to practice related questions or reinforce your understanding, you can visit our educational website by clicking the link in the top right corner of the screen or use the link provided in the video description to go directly to this specific lesson.